Yeah, so let us do the next part. Next part is gradient. Gradient of a scalar field. What do you mean by gradient? Let S, which is subset of Rn, be a non-empty open subset of Rn, and let E belongs to S. Okay, let F from S to R, since it is scalar field, uh, be a scalar field such that each of its partial derivative, that is dou f by dou xi, exist for all I equal to 1 to up to n, then the gradient of the function f at E, denoted by del f of A, this is called del f of A, is defined as this: del f of E, that is equal to dou f by dou x1 at E, comma dou f by dou x2 at E, yeah. So this is the definition. So do you see the gradient vector? This guy is called del, and del of f of a is defined as dou f by dou x1, first coordinate में x1 से, second coordinate में x2 से, and like this the nth coordinate will be dou f by dou xn. So do you see this is a vector? Okay. So you may do some examples also, calculate the gradient of the function. Let us do the first example. If you are given f from R3 to R, and f of xyz is equal to say 4x cube minus 9x square yz and plus 3zy square. Find del f at 1 2 comma minus 3. Correct? So how do you do? See, this is a polynomial function. You can easily find fx. Correct? What is fx? You have to do partial differentiate with respect to x. So ये क्या आएगा 12x square, यहाँ पे क्या आएगा minus 18xyz, and here it is 0. What is fy? Fy will be, this is 0, this will be minus 9x square z, and here it will be plus 6zy. Correct? And what about fz? Fz will be, this is gone, this is minus 9x square y and plus 6zy. Correct? This is your fz. So fx, fy, fz मिल गया. अभी क्या निकालना था? del f क्या होता है? del f at at 1 2 3 ना, at 1 2 minus 3, that is equal to what? Fx at 1 2 minus 3 comma fy at 1 2 minus 3 and fz at 1 2 minus 3. You just need to put the value, and you see यहाँ पे 1 2 minus 3 put किया तो क्या आएगा ये 12 square. So this is 12 into x का वैल्यू 1 है, minus 18 into 1 into 2 into minus 3. Correct? And similarly like this, I'll directly put the values. Maybe you just try to see. The answer will be 66 minus 9 and 3. You just quickly verify whether you are getting. Now see, in this this was easy to find partial derivative, huh? But the function need not be this always. I'll show you in next example. Tell me once you are done by verifying. This is 3 directly because uh, this will be minus 18 plus 12, minus 18 plus 12. So that's why. Should be fine. No, I think there is some error in that. What are you getting? Anybody? This is 12 minus, it will be minus minus plus 18 into 6, comma, it will be 9, 9, 18, and it will be minus 6 into 6, comma, the third one would be minus 18 and plus, wait, plus 6 into z, na? So it will be, wait, 9, see y is 2, so 9 to the 18, and this is 6 into z into y, na? So z into plus, it will be 36, correct? And it is minus or plus, could be in minus again. Right? You calculate and see what you will be. Okay, so this is okay. Let us go ahead to the next example. Yeah. So in the next example, let us take this function from R2 to R, that is given by f of xy is equal to xy square upon x square plus y raised to 4, correct? For x non-zero, find del f at 0 0. Do you see, if you try to solve this with your u by v rule, and that will be quite difficult. Do you see that? Not difficult, that will be quite lengthy, but if you go with formula method, then it will be easy, correct? Anyway, the choice is yours. Mine, I can just give you a suggestion. If you go for fx, then you have to take u by v and do that. But better you use this. Do f by do x. What is definition? At 0 0. The definition is this: limit h tending to 0. Coordinate changes will be in this first coordinate, that is 0 plus h comma 0 minus f of 0 0 upon h. Correct? And let us put it quickly. Do you see one line answers? This will be h comma 0 at the place of this will be 0, so it is 0 minus 0 upon h, that is 0. fx aa gaya fatak se. Same fy will be what is the formula? Limit k tending to 0, it will be f of 0 comma 0 plus k minus f of 0 0 and divide by k. You see that again you have to do the same thing, 0 comma k. It will be, I think, again 0 minus 0 upon k, that is 0. So what is your del f at 0 0? This is equal to fx at 0 0 comma fy at 0 0. That means it is 0 comma 0. Correct? Yeah. So you see that gradient is a vector quantity. Huh? And next comes algebra of gradient. That is easy to see. That means first one would be del of f plus g is equal to del f plus del g. सेम अगर प्लस की जगह माइनस रखा तो यहाँ पे माइनस आएगा. What is second? Del of alpha f, that is equal to alpha del of f. Third, del of fg, it will be same जैसा उधर था. Say I am talking about a point, that e, it will be equal to f of e del g, uv rule था ना, and plus g of a del f of a. Correct? And the fourth one will be del of f by g at e, it will be equal to g of e del f of e minus f of e del g of e divided by g of e the whole square. You already know what is the definition. You can prove it easily. Here the condition is g of a should not be 0 and g of x also should not be 0. Correct? Yeah. In a neighborhood. In a neighborhood of a. Okay, and proof is easy. It is just coordinate wise differentiation. So I don't think so I should do that. Let us do one example quickly. Suppose f of xy is given to you, that is 3x square plus 9xy, and say g of xy is given 4y square plus 7x. So the question is find del f, del g, del f plus g. Next is del f minus g, del f into g. Next, del f by g. Correct? At 1 comma minus 1. So do you see, you just have to calculate what? You just calculate f of a, g of a, del f of a and del g of a. Correct? Others will follow from the formula. I hope you agree. You don't have to do all the time. Calculate f minus g and do that. You just use the formula. So what is f of a? F of a will be, you just need you need to put the value 1 and minus 1 in the function. So if you put 1, so it will be 3 minus 9, that is minus 6. First is done. G of a will be 4 plus 7. So what is that? 11. Correct? And what is del g of a? fx से किया तो ये क्या आएगा? It will be 6x plus 9y at which point 1 comma minus 1. Just put it quickly. We see. Sorry, del f of a ना, तो इसमें दोनों कोऑर्डिनेट आएगा ना. This is fx हो गया, and what is fy? It will be just 9x. Correct? Put 1 and minus 1 and see what is the answer. Same here also. G with respect to x किया तो it will be 7. With respect to y किया तो it will be 8y. If you put 1 and minus 1, it will be 7 and minus 8. And यहाँ पे भी कर लेते, तो ये क्या आएगा? 6 minus 9. So 6 minus 9 is minus 3. Correct? And what is this? 9x, so it will be just 9. correct? So this is your, you can easily get this delta f plus g, del f minus g, del f into g, del f by g by using the formula which I just wrote to here, correct? Yeah, okay. Next part is the relationship between total derivative and gradient, which I have already given you. Just it is just to state total derivative and gradient, correct? So that means you can find total derivative by the help of gradient also, correct? Let me just state. Let S be a non-empty open subset of Rn, subset of Rn, yeah, and let us take if f from S to R is differentiable at E which belongs to S, then gradient differentiable है तो gradient of f at E exists because gradient क्या है, the coordinates are partial derivative, so function is differential, then each coordinate is exist, and so del f is exist, and total derivative of f at E, that is equal to df of A, and that is given by t, and where t of h is equal to del f of E into h. That means what? This is h1 uh, fx at e1 at e comma h2. This is coordinate, huh? So dot product will be, it will just give me addition h2 fy at e plus h3 fy at e, and so on. That is hn f सॉरी एफ एक्स वाई नहीं लिखना चाहिए, एक्स वन लिखता हूँ मैं, एक्स टू लिखता हूँ, एक्स थ्री, दिस इज एक्स एन एट ए, करेक्ट? So you can calculate the total derivative by simply this. So let us see one example of this. Actually, we had done so many questions related to that. Actually, before going to the example, let me just reframe the definition of total derivative. So the new definition of total derivative will be, like I can say, f is differentiable at E belongs to S, then that means the limit S tending to 0, f of E plus H minus f of E minus, at the place of at the place of T of H you can write del f of A dot H, correct? Because now you know what is your T of H, and divided by norm H, that is equal to 0. This limit should be, then it is, say, function is differentiable. You are having a new definition of differentiability, correct? And also directional derivative can also be written as in terms of, because we have given a theorem that is directional derivative in terms of total derivative, correct? So now we can write directional derivative in terms of your gradient. I'll just quickly state that. Let S be a non-empty open subset. So gradient से हम लोग को सब मिल जाएगा. Let f from S to R is differentiable at E, then for any unit vector V, U in Rn, the directional derivative of f at E in the direction of in the direction u, no? U is given by, that is du of f of a, that is equal to del f of a into u, dot product with u, correct? So you remember you can now calculate anything, total derivative हुआ, directional derivative हुआ, correct, by using just gradient. So see, the gradient is so important for us. So to calculate total derivative, you just have to do that one. Yeah. And the one more application of this gradient is this. I'll write it as a corollary. Most important, mostly asked in IIT JAM exam. That is, I'll write let S be a non-empty open subset of R. Let F from S to R be a scalar field. Let E belongs to S, and gradient of F at E exists. Okay, then F undergoes maximum rate of change. Maximum rate of change at E in the direction of delta f of E, and F undergoes minimum rate of change at E in the direction orthogonal to delta f. In the direction orthogonal to delta f. You just remember these two things. That is, if somebody asks when does f undergo maximum rate of change, when in the direction maximum rate of change in this direction, and minimum rate of change in orthogonal to this direction, delta f. Okay, and that is easy to see because see what is your directional derivative, du of f of e, that is equal to del f of e into u. That means what, अगर डॉट प्रोडक्ट को सॉल्व किया तो क्या आता है, norm of delta f of e, correct, into norm u into cos theta, correct. That means our norm u is gone, so this is norm of delta f of a into cos theta. What do you mean by this? Cos theta is the angle between delta f of a and u, correct. So du f of a is maximum when cos theta is maximum. Cos theta maximum कब रहेगा, जब theta equal to 0. So maximum rate of change is parallel to delta f of a, and minimum rate of change will be when theta is 90, that is orthogonal to. Correct, orthogonal to that. It is just depending on theta. Minimum rate of change will be when cos is negative. Cos is actually 0. We'll just wait for the network. Yeah. So from this it is clear that whatever I have written in the above, maximum कब रहेगा when theta cos theta is maximum. Cos theta maximum कब रहता है when theta is 0. And minimum it is theta is 90. Let us write one remark. Now, yeah, the direction in which f increases most rapidly occurs, occurs in the direction of delta f, that is when cos theta is 1. Correct? In the direction of delta f. When cos theta is 1. Okay? The direction in which f decreases most rapidly occurs in the direction minus in the direction of minus delta f, obtained when cos theta is negative, cos theta is minus 1, when theta is pi. Correct? So these two things, remember, I'll just mark that. Increases most rapidly in the direction of delta f and decreases most rapidly in the direction of minus of delta f. Correct? So we'll do problems in the next lecture and also the mean value theorem also. Everything we'll do in the next lecture.